the value of d, given that you have k to the power of 6 equals open parenthesis 2 minus k close the parenthesis to the power of 6. Then let's have it to be solution from here. Then let us recall from the law of indices that when we have a to the power of m, they are equivalent to b to the power of m. So far they have the same power. This implies that the base are equal, meaning we can equate the base. So from here, obviously, a equals b. Now from here, k to the power of 6, this one has power 6, this one also has power 6, meaning that we can equate the base to be equals, k will be equals 2 minus k. Then when you collect the like terms, we have k. When this one come here, we have plus k, then equals 2. So from here, we have 2k equals 2. And so therefore from here, when we divide 2 by 2, here will be k equals 2 divided by 2. So we have k to be equals 1 as the first solution. So k equals 1 is the first real solution. But I must tell you that k equals 1 is not the only solution for the problem given to us. Then let's see how to find the rest of the solution. So we have k to the power of 6. We can simplify 6 as 3 times 2 equals, open parenthesis, 2 minus k to the power of 6 as 3 times 2. Recall that when we have a to the power of m times n, it can be written as a to the power of m in parentheses to the power of n, and also equals a to the power of n in parentheses to the power of m. So when you apply it here, we can have it as k to the power of 3 in parentheses to the power of 2, then equals, open parentheses, 2 minus k to the power of 3, again in parentheses to the power of 2. Then let's take this one here. So we are going to have k to the power of 3 in parentheses to the power of 2, then minus, open parentheses, 2 minus k to the power of 3, again to the power of 2, equals 0. Now, mere looking at this expression, we can see that we have 2 here, we have 2 here. By applying difference of 2 square, because of this negative, that says when we have a square minus b square equals as a plus b multiplied by a minus b. So meaning that from here, our a will be equivalent to k to the power of 3, and our b will be equals 2 minus k to the power of 3. So we have here to be k to the power of 3 plus, open parenthesis, 2 minus k to the power of 3 as this. Then we have all the in brackets, then multiply by k to the power of 3 minus 2 minus k in parentheses to the power of 3. Then we have everything to be equal 0. So from here, now let's see case 1. Because we must understand that for this expression to be equal 0 from here, it's either this one equal to 0 or this. Either of the one must be equal to 0. Then if this one equal to 0, meaning we are going to have k to the power of 3 plus, open parenthesis, 2 minus k to the power of 3 equals 0. Recall from the sum of the two cube, because of this power 3 and 3, when we have a to the power of 3 plus b to the power of 3 equals as, when we have a plus b, then multiply by a square minus ab plus b square. So from here, when we apply this one, we are going to have it to be k plus this will be 2 minus k, then multiply by k square. Here is a is k, b will be 2 minus k, then plus 2 minus k square, then everything equals 0. So from here, we have this k, we cancel this, we have here to be 2, here will be k square. When you open the bracket with this, here will be minus 2k plus k square. The expansion of this one, the expansion of this will be 4 minus 4k plus k square still equals 0. When we divide through by this, we are going to have it only to be k plus k square plus k square plus k. We have it to be 3k square minus 2k minus 4k. We have it to be minus 6k, then plus 4 equals 0. Now we have 3k square minus 6k plus 4 to be equal 0. So by applying the quadratic formula, where we are going to have k equals minus b, positive or negative, square root of b square minus 4ac divided by 2a. So from here, we have the parameter a, the coefficient of k square, we have 3. Parameter b, the coefficient of k, minus 6, and c will be equals 4. So from here we have k minus outside minus 6, positive or negative, root of minus 6 in parentheses to the power of 2. 4 times a is 3 times 4 divided by 2 times a, 3. So from here, we have k, we have it to be 6, positive or negative. Here will be 36. 4 times 3, 12 times 4 is 48, divided by 6. So from here we have k, 6, positive or negative, root of 36 minus 48 will give us minus 12, divided by 6. But we can have 12 to be equals 4 times 3. So we have k to be equals 6, positive or negative, root of 4 times 3 multiplied by root of minus 1. This negative divided by 6. So from here we have k to be equals 6, positive or negative, root 4 will give us 2, root 3. Then let us note that when we have root of minus 1 equals I in a complex number, so all divided by 6, k will be equals, let's divide through by 6, positive or negative, 2 multiplied by root 3 divided by 6. So here will be 6 divided by this will be 1, positive or negative. From here, this will be 2, here is 1, 2 in this will be 3, here will be root 3i, then divided by 3. So where we also have k to be equals this. Then let's say case 2. For case 2, we have k to the power of 3 minus open parenthesis 2 minus k, close it, to the power of 3 equals 0. So from here, when we have a to the power of 3 minus b to the power of 3 equals as a minus b, then multiply by a square plus ab plus b square. So from here, we have k minus, this will be up into 2 minus k, then multiply by, this again will be k square plus k multiplied by 2 minus k, then plus 2 minus k to the power of 2 equals 0. So from here we have k, minus times minus will be minus times plus, here is minus, here will be plus k, then here will be k square, here will be 2k minus k square plus, here will be 4 minus 4k, then plus k square, we close it, equals 0. So from here, k plus k will give us 2k minus 2. So from here, this k will cancel out this. We have only this k left. We have plus 2k minus 4k, here will be minus 2k. Then from here, we have plus 4, all in parentheses, then equals 0. Let's factor 2 from here. Here will be 2, here will be k minus 1 multiplied by k square minus 2k plus 4 equals 0. So dividing through by 2, here will be k minus 1 multiplied by k square minus 2k plus 4 equals 0. So from here, for this expression to be equal to 0, it's either we have k minus 1 equals 0, or we have k square minus 2k plus 4 equals 0. Then from here we have k to be equals 1. Then from here is again we have k to be equals minus b positive or negative root of b square minus 4ac divided by 2a, where we have a to be the coefficient of k square, which is 1, b to be the coefficient of k minus 2, and c equals 4. So from here, we have k minus, is here is already minus, here will be minus outside into minus 2, positive or negative root of minus 2 in parentheses to the power of 2 minus 4 times a is 1 times c is 4 divided by 2 times 1. So we have k equals minus times minus will be plus, positive or negative roots of this will be 4, this will be minus 16 divided by 2. So from here we have k equals 2 positive or negative, here will be root of minus 12 divided by 2. So from here we have k 2 positive or negative, this will be 2 root 3i divided by 2. When we divide through by 2, we have it to be k equals 2 divided by 2 positive or negative 2 divided by 2 multiplied by root 3i. So we have this to be k equals 1 positive or negative root 3i, and also we also have 1 positive or negative 3 roots 3i, then divided by 3, and we also have k to be equals 1.